Alrighty, let's get started. Hi, everybody. This is Christiana from the Coiled team. I'm so excited to welcome you all to Coiled's August webinar, The Open Source Data Tooling Landscape, with our guest Carol Willing, the VP of Learning at Noteable. And our host today is going to be Coiled's very own Hugo Bone Anderson. I'm about to introduce Hugo, but just as a reminder, we'd love for you to introduce yourself in the chat and make sure that you set that towards chatting to everybody so everybody knows where everyone's tuning in from. But without further ado, I'm going to introduce Hugo. Hugo Bone Anderson is head of data science evangelism here at Coiled. He has extensive experience as a data scientist, educator, evangelist, content marketer, and data strategy consultant in industry and basic research. He also has experience teaching data science at institutions such as Yale University and Cold Spring Harbor Laboratory, conferences such as SciPy, PyCon, and ODSC, and with organizations such as Data Carpentry. He is committed to spreading data skills, access to data science tooling, and open source software, both for individuals and the enterprise. And he's also an excellent webinar host. So without further ado, I'm going to introduce you to Hugo.
Thank you so much, Christiana. And you're absolutely right. So Hugo here, I am absolutely committed to spreading the joy and skill set of data tooling around the globe. And that's why I'm so excited to have guests such as Carol to come and chat about all this incredible stuff, particularly when the space is growing so quickly and it's so challenging to even figure out what the tools are, let alone how to use them. So that's why I'm really excited to be chatting with Carol today. I'll introduce Carol in a second, but before I do that, I'll just tell you a bit about what we do at Coiled. So what we're really excited about doing with Coiled is helping data scientists use Python for large-scale problems, scaling to the cloud for computing power, ease, speed, all tuned for the needs of teams and enterprise. And if you want to check out what we do at Coiled, we'll share the link in the Slack. In the chat, and you can try Coiled Cloud for free. So essentially, what we're currently doing and what you can leverage Coiled for is hosted DAS clusters. So you don't need to worry about any of the DevOps stuff, containerization, all of these types of things. So we have one-click hosted deployments that allow you to get your DAS clusters up and running with the click of a button on the cloud. So check out the link that Christiana will provide in the chat. Try it out for free and get in touch with us. Join our Slack community or email us at support@coiled.io in order to let us know how you go with Coiled Cloud. So without further ado, I would love to introduce Carol. Okay, so Carol is of very, very many things. And yes, I will share my video. I mean, nobody tuned in to see my face, but I'll turn on for a second. Carol is the VP of Learning at Noteable, as well as a Python Steering Council member and Project Jupyter core contributor. So that's a Venn diagram to really get the pulse racing. She's also a leader in open science and open source governance, serving on Quansight Labs advisory board and I'm sorry, because because I've lived in America for so long, but I'm back in Australia. I'm actually deeply confused around Z's and Z's currently and spelling in general. But CZI Open Science Advisory Board. Carol is driven to make open science accessible through open tools and learning materials. And that's one of the many reasons we love chatting so much. So before we get started, Carol, I thought I'd just say, hey, how are you?
I'm much better now that I found the unmute button. I'm doing great. You're right, as great as can be in these times, but I'm working on things that I enjoy, in the notebook space, as well as data science, and still getting to do all the wonderful open source stuff that is really where my heart will always be.
Mm.
So yeah. What about you?
I'm well. As you know, I'm on the other side of the globe and in the future. So it's Wednesday morning. So halfway through the week. Currently in lockdown, which of course is for the greater good, but it has been a couple of months, so it's getting pretty itchy. But having said that, I've got wonderful things to work on and wonderful conversations to have like this. So I'm definitely grateful for those things.
Thank you. It's an honor for me. So I've been looking forward to this.
Awesome. So why don't we jump in? If you share your screen and we can get going. And what I'll do is I'll encourage everyone to ask questions. There's the chat box, but there's a Q&A box. So if you ask the questions in the Q&A, we'll get to them. And feel free to ask as many questions. I'll endeavor to be respectful of the story Carol's trying to tell, but I may interrupt at certain points as well with any questions that seem super relevant at the time. And the rest will hold off until the end of the presentation. But ask as many questions in real time as possible.
Yeah, I mean, I would hope this would be interactive because that's sort of how I roll. And I think it's how we get great ideas fostering in our communities and how we build cool stuff.
Absolutely.
So without further ado, I'm going to talk a little bit about the open source data tooling landscape. And I want to start with XKCD, because what presentation doesn't start with that? But on a more serious note, Vanessa Sackett had a really great article recently about the 10 best practices for remote software engineering. And since we all are now, for the most part, remote, I thought that this was particularly timely because, we don't know how long this is going to go on for. And it's really incumbent on all of us to take care of each other because 2020, 2021, and quite likely 2022 are going to have little asterisks or symbols next to them in all of our data sets. And so, be good to yourselves. Do check out that article. It's really good. Vanessa is also a research software engineer and does RSE Stories podcast. So pretty good stuff all around. So I want to start by looking at some common data challenges and some of the solutions that we might offer to those challenges. And interestingly enough, these are challenges that I saw back in 2015. So at that point, IPython was probably 14 years old, I think. And Jupyter Notebooks was just a baby. And the PyData stack that we know, NumPy, scikit, Learn, Pandas, and Matplotlib had been around in the years between 2000 and 2010. However, most of the projects that many of you are working with, including Dask and the Jupyter Notebooks, they've really been around for less than 10 years. I mean, Docker was introduced in 2013, Kubernetes 2014, Jupyter Notebook, Jupyter Hub 2015. So in less than 6 years' time, we've actually seen tremendous growth in Python and its use with data science and the tooling around that. And I think one of the things that has impacted us is the ability to deal with data at scale. And data at scale, both on-premise or in the cloud, data at scale that you might already have if you're an enterprise that has already been there for several years, so you're not going to necessarily switch over immediately. So scale is something that is just prevalent within our ecosystem. Speed, we can never have enough of it when it comes to network speed, processor speed, and actually just the speed with with which teams come together and actually solve problems. As we talk about people coming together, there are so many different connections that people have to make, not just technical ones with your network, but also for people. Like, who do you follow? Who do you go to when you need more information about something? And it's all of those connections that actually impact how you approach a data science project. And finally, choices, which I think may in fact be the hardest of the bunch, because there's so many different tools out there and so much different information that we get from open source projects, from marketing and other things, that making a choice of even where to start can be really daunting sometimes. And I'm going to talk a little bit later about trying to put together a taxonomy of open source data tools. And the choices are complicated, but hopefully we can talk about them and make them a little bit more accessible for folks. So many of you have heard the term data pipeline, and data pipeline, you know, I bring in data either through sensors or people's interaction with my website, all the way through satisfying the user on the other end. So whether it's delivering in retail, you know, products that they've ordered, or delivering healthcare to folks that need it at the right time in the right place, all of that is served by a data pipeline. And we often talk about the tools themselves and the technical tools, and we'll talk about those in this talk, but I want to first step back, because I think something that's equally as important as the tools is the people behind the tools, the people using the tools. And I want to look at them from a few different perspectives. First, I want to look at it from the perspective of business executives or people that are really managing like profit and loss, bottom line. They're hearing, okay, I need data science, I need deep learning, machine learning. I don't even know what it is necessarily some of the time. And because I hear that there's opportunity to be had. Now, at the same token, if I was dropped in the middle of the deep learning space at this point in time, I would have a hard time deciding which library to choose. Do I choose TensorFlow, PyTorch, FastAI, and something yet to be written? So executives kind of have a hard job, and they are the ones that are going to be accountable in the end. Now, I'm lumping together many software engineers into this process, because otherwise the people around the process will be too much for us to like cognitively get. But I'm using software engineers as people who are building the infrastructure that our data pipeline runs on, people who are like data engineers that are a key part of the process for getting us the data, getting the data into a format where we can use, so all the data cleaning, data wrangling. And oftentimes, the amount of information that they need to know about the tools and is really vast, and it has changed a lot. Kubernetes really, you know, as I said, it was introduced in 2014, so 7 years ago, has profoundly changed cloud computing and how people approach cloud computing. And so the folks that are data engineers or software engineers, DevOps engineers, have a lot on their plate with not a whole lot of history behind it that they can draw upon. There's also data science.
I'll just add there, Carol, I love that you've sliced it this way, but mentioned that there are kind of further segmentations to take place. I am really excited about the specialization we're increasingly seeing, as you've kind of hinted at, into ML engineers, data engineers, infrastructure engineers, DevOps in general. I think it's worth calling out that a lot of data scientists currently end up doing a bunch of these things as well. And perhaps I'm jumping the gun there. You're getting there.
No, actually,
how many times I've heard data scientists end up being DevOps engineers.
Absolutely. And I think that's one of the biggest challenges we have now with data pipelines and successful data projects is you can't know it all. There's way too much for any one person. You could be the best data scientist in the world, but you're not going to know the ins and outs of Kubernetes, quite likely, or the ins and outs of authentication or other engineering pieces that go into offering those services and using our data. And, the reality is, most of the time data scientists want to do data science. They don't necessarily want to be the DevOps engineer of their project, and they're doing it by default. So, I think you want the data scientists to do what they do best, look at the data, determine, is the data biased? Is this a good model for us to use? Has the model run its course? Is it drifted from its original intent? All of those sorts of things are stuff that the data scientists would be better positioned to answer than to be spinning up another Docker container.
Yeah, I wonder if there's a variation on what is now the old adage, like 80% of data science is cleaning and data preparation, that, X% of data science now is turning into DevOps, right?
Yeah, well, it's interesting. It's definitely like, if you look at like a life cycle model in business, you're seeing like we went through the rapid early adopter growth phase, like, with Jupyter and, the Python, PyData ecosystem as a whole. And now it's like, okay, we've gotten to a point where we need to really scale some of these things. And that's a whole different playbook than what we've had before. And there's different variables that factor into that. And the last group, and perhaps the most important group, is our users. They're looking for productivity. They're looking for their needs to be met, whether it's groceries delivered to their door during a pandemic, or, the latest and greatest, I don't know, I'm just going to date myself and say CD, but TV, how's that? Or monitor.
I wouldn't mind a CD, in all honesty, but
there was something about the physical, but that does date me. So the data pipeline, the best recommendation that I can give is to start small, to experiment. And this is actually surfer Justine DuPont, and she's a big wave surfer. And by starting small, you can make small incremental mistakes. It's how we developed Binder. It's how we developed Jupyter Hub. And it's how I've watched Dask evolve over the last 6-7 years. And in addition to starting small, you can then scale and feel comfortable scaling, as opposed to starting at scale when you're a brand new surfer, ready to be drowned in data galore of many different shapes and sizes. So I think, much as we want to say, okay, we want to scale on day one, that isn't often the best strategy. And looking at projects that help you scale, have been proven to have a model to scale, I think is really important in this. So now, getting a little bit more technical, I want to look at the open source data tooling landscape. And as I said before, it has sort of exploded in the last decade. So not only do we have to consider the Python ecosystem, but there are many other open source languages that we even use within open source data project or within our data projects. And R has been around for a long time. Julia is, an interesting language, relatively new, coming on. Fortran, still around, still kicking, still being used. SQL, same as, and those are really languages that have been used in some way for data analysis and computation. Now, that said, many of these languages also fall into other categories as well. Workflows, getting things done at scale, the infrastructure work, C++, Go and Rust that have a little bit better memory handling ability. Java, there's lots of it out there in the enterprise, and Scala and Spark. And then something that I think is really interesting, because we've become so web-centric and cloud is such a big thing, interactivity becomes more and more important. And, JavaScript can't be discounted in, TypeScript in order to have good types within JavaScript, but because I think it's going to give us some of the rich experiences that the end users want. And, it may also be a packaging vehicle down the road as well. But now let's step back and think of our data scientists from before. If you're a data scientist and you know Python really well, but then somebody sends you a model from Julia and then tells you to deploy it on Kubernetes, which is based on Go, things get complicated really quickly because each of those languages has their own libraries and open source tooling that they use to make their users efficient. So we talked about the languages a little bit and the data workflow. Now, oftentimes we see this as sort of a linear progression like I have here, like you define the project, collect the data, do the wrangling, use your visualization tools and your basic statistics to do some exploratory analysis. Then you're doing some computation and modeling, reevaluating the results from that computation, sharing and communicating what you found. And should you find a diamond in the rough, then deploying that at scale. And then as it's deployed, you have a lot of monitoring and double checking for drift and things like that. And ultimately, you're going to revisit your technical goals, your business goals. And while this sounds really good as the pipeline, in practice, we're going back and forth between these steps. And it looks much more like a graph, like a network graph, than strictly, one step, next step, next step. And I think that's sort of how we have to start looking at some of the stuff and some of the tools. Now, these were the categories that I came up with. And there's some challenges with that because there isn't really a de facto set of these are the steps in a data workflow. They're kind of fall in these things, but they're often called something different, or some of them are combined, some of them are split up. And so the challenge is, first and foremost, the foundation that our business is built upon, whether we have existing infrastructure, whether we were an early adopter of the cloud services, whether we have a hybrid. And that can include both our compute as well as our stored data or data that's coming in on a regular basis. And so people are going to start from different foundations. So different tools are needed for different foundations. Now, by the same token, there's variability in how companies manage their resources and services. anything from do it yourself, let me install it on bare metal, to I want Coiled to handle everything related to anything that I want to do with Dask. And I just want to know that the best and the brightest are using it. And for there, you will go forward. Again, different tools depending on which approach you take. Then there's always complexity in the projects themselves, and particularly managing it from start to deployment at scale. Each language has its own ecosystem of tools, from packaging, package managers. They don't all work together. They don't all interoperate. And so when you're doing new deployments, you've got to take that into account. And another challenge has been the phenomenal growth of these libraries and tools. 10 years ago in Python, it was pretty straightforward. You had scikit-learn, you had matplotlib, you had pandas, you had NumPy, SciPy, and IPython. And that's pretty much what you had. And so there weren't a whole lot of choices, but with growth, we now have many more choices than we ever had before.
And I just want to note, Carol, one thing. When you mentioned complexity, you mentioned package management and dependencies and these types of things. And for a lot of people who haven't worked with these a lot, that may seem like a detail, but it's actually so deeply fundamental. And if we look, one story of Kubernetes, right, is we were trying to do local package management stuff and get that up and running with, you know, our environments in other places, such as on the cloud. So containerization became a thing, right? Mm-hmm. But as it so happens, when you do kind of long workflows and data pipelines and projects, you might need different containers at different parts along. So maybe you need something to containerize your containers. And that then leads to something like Kubernetes, right? So it's containers all the way down in some ways, but it's a huge challenge that plagues us all and gives us night terrors.
I'm glad you pointed that out, because on Jupyter Hub and Binder, we jumped onto Kubernetes in the early days when Kubernetes was maybe like 0.7, and have continued to, or 1.07. And the biggest challenge was it was different to install Kubernetes on each cloud provider. So we were maintaining directions for Google Cloud, for Azure, for AWS, and it was a huge burden on the open source maintainers because we didn't necessarily have experience with those that tooling. And quite frankly, some of the companies didn't have the experience that they needed with Kubernetes to then get you up to a point where you could install a Helm chart, which is basically the ecosystem of Kubernetes containers land. So it is a huge issue. And one that, because there's so much complexity and so much variation in tools, that, you know, there aren't necessarily best practices or de facto standards for everything. And maybe not even the big chunks that you do in your data pipeline. Another thing that we find is jargon is something, you know, what we call things, how we language, how we talk about storage, whether it's, you know, people call things differently. And then they also, you know, as they're trying to hype things for marketing and things like that, the story gets even more complicated because there's other terms that are associated then with the open source tool because it's being productionized by other companies. And the only standard that I could really find for sort of a data workflow was one that was developed in 1996 for SPSS, a statistics language. And it sort of had similar steps that we have in our pipeline, but right smack and dab in the middle is a mainframe. So we could almost put the cloud in there. And I think one of the things that we see in this open source tooling is we're very much abstracted from the hardware, and there's many layers of abstraction. I don't really, as a data scientist, care how Kubernetes works under the hood, but sometimes I have to know that in order to get my project done. And those are the things that are challenging on a day-to-day basis, because they tend to be roadblocks or bumps in the road, if you will. So what I tried to do, and it was perhaps a foolish endeavor because I've had several weeks to think about this and mull it around in my head, but I wanted to do a taxonomy of open source data tools. And this particular taxonomy sort of took the bigger picture items like data preparation and broke it into things like cleaning, labeling things, validating that data is in fact accurate. And from there, and good taxonomies aren't done typically by one person. They're typically kind of gotten to by a group of people. So hopefully there's some postdoc out there or PhD student that's looking to have a really meaty project. Creating a taxonomy for open source data tools would be a great project for that. So I started by looking at Python, and then there were so many different packages that it quickly became overwhelming, because it's like, okay, which packages do I choose? Which ones do I put on the chart, for space? But in many ways, Julia is closer to where Python and PyData Stack was in sort of the, late 2000s. And just from the simple thing that it's a newer language, there aren't as many tools, there aren't as many packages. There's pretty much one way that you deal with data frames, couple, three, well-known visualization libraries. And it was easier to come up with, okay, these are the libraries that would go with those steps in the process. Now, in full honesty, many of the steps in the process overlap and have similar functionality. Like my exploratory analysis, I'm doing visualization. So I'm needing visualization tools. But then I also come back and I need visualization tools when I'm sharing insights and content with others or making dashboards or web apps. And so while functionally it might be clear, practically it gets blurred really quickly. And I did a similar exercise for Python, and I left most of the projects out. I kind of put sort of my favorites in here, but somebody could definitely flesh it out, because I could not find anywhere like a canonical list of everything that we have out there. And even if I did, it would be different 3 weeks from now with new projects coming on board. And I think this goes back to your point, Hugo, that, when you look at a data scientist that's trying to do DevOps and workflows and scheduling, there's too many bits and pieces and libraries to get it done well without help. And I think that's where the de facto standards and things like Jupyter Notebooks was a big help, because it was like, okay, we could all have like a common compute platform. But even more importantly, the IPYNB files, while JSON might not be the best way or the perfect way of sharing things, it gave people a de facto standard, much like a PDF is a de facto standard for sharing of information. And not to leave out R, because quite frankly, I think they have some really great stuff. And I think most data scientists that I know kind of bounce between certainly R and Python, and increasingly Julia as well. One of the nice things that they do have, actually two, OpenSci has sort of culled out packages for you for different aspects of this workflow. And as well, Tidyverse does a similar function. And nicely, RStudio kind of bundles it all together. And so it makes things a little bit simpler, but you still have a ton of packages out there and you're still making trade-offs with things.
Yeah, part of me hesitates to say anything because I think whatever I say will like start some language flame war of some sort. But I do think there are pros and cons of let me say the tidyverse, okay, which is a particular part of R that is very popular in the data science community. It's perhaps, let's say, more opinionated about what tools to use for what things than Python and PyData is. So I'll give data visualization as an example. It's relatively standard to use ggplot2 in R. And this is actually a complaint of people who use R going to Python. They're like, oh, wait, do I use matplotlib or Seaborn or Bokeh or Altair? And there are pros and cons of both, right? But I think a challenge in Python is to provide good resources and awareness of what tools may be most suitable for what challenges and questions you're trying to answer, so that beginners in particular kind of aren't overwhelmed by the space, so to speak, if that makes sense.
Right. And I think that also speaks to, okay, why open source versus proprietary systems? And personally, I feel like open source, you're going to get the innovation sooner. You're going to be able to sort of introspect what is going on within your data pipeline and your workflow. And by that, I mean, you are able to do reproducibility and auditing, let's say, on a machine learning model that has been used for healthcare or making financial decisions. That would be perhaps harder to do and less transparent if you were using a number of proprietary solutions. Now, one of the things we've seen, certainly in the last 5 years, is that hybrid of taking open source projects, like Jupyter or Dask, and building companies on top of them that hopefully give back to the projects themselves and are not purely an extractive venture. But it is open source, so even if it was purely extractive, that is certainly the prerogative of people, although it doesn't help the ecosystem as a whole. But I think there's a lot of ways you can look at this, slice it, cut it. It was my first pass at trying to come up with a taxonomy, because one of the things that I found, I'm going to go through a couple slides and then we can kind of open it up wider for questions. But oops. I took a recent course back at MIT, well, virtually, because I couldn't go back right now, but it's called Algorithmic Business Thinking. And basically it was a way to think about and language business-centric concepts, which are like the human-centric concepts, with the technology itself. and the tooling, and to make it so that, you know, people can communicate, whether they're on the tech side of things or the business side of things or anywhere in between. And so there's like a periodic chart of, you know, things, and one of the concepts is also like a DNA helix. We often talk about tech over here, business over there, when really they're much more intertwined, much like, you know, the double helix. And I just thought I would share it with my open source and enterprise friends, because it's really the first time I've seen that languaged well. And it also brought in research from a number of other people, both on the technology side, CS side, as well as, you know, organizational behaviorists, and also business folks as well. So my parting words are sort of, if you've got data at scale, my default is to go with open source tools at its foundation. And beyond that, look for ways that those tools can be managed well for you, so that you don't have to do all the details unless you want to do the details. And that's pretty much what I got.
Awesome. Thank you so much, Carol, for that wonderful presentation. I just want to encourage anyone who has any further questions to ask them in the Q&A section, and we'll definitely try to get to them. We actually have a comment that I'm going to try to make it so we're both visible. We should be both visible.
You want me to stop sharing?
Oh yeah, we might as well. And if we want to have a look at some slides, we can do that. Tom Brown commented. He wrote, "End-to-end workflow is the challenge in Python," and I thought maybe you could speak to that.
End-to-end workflow, like, you know, getting Python installed all the way to getting the model out the door. Is that?
That's all he wrote. So, but that's my understanding, or perhaps maybe not the installs. The way I could interpret it is, oh no, he wrote yes. Great.
Okay, yeah. So another history lesson, because the PyData stack evolved later than the core language itself, as well as all the web libraries like, you know, Flask and Django. There has been growth of more than one packaging tool and more than one packaging source. So pip, you know, is, you know, the collection of PyPI projects and how you can install those. Conda, you can use to install Anaconda, you know, packages that are through the company themselves, or you know, Conda Forge, you can get them as sources. But installing Python, it's better than it was 10 years ago, but we still have a ways to go. And some of it is getting that. I don't think we will ever get consensus to go to one package manager. So I know one of the things that we're thinking about is, okay, how do you get the information out? And, you know, even which tools to use. It's something that internally at Noteable, I've really had to work with my peers on, because, you know, at some point you're going to want to lock down those versions, that even down to like a very specific thing if you're running in production. And, you know, but I think even abstracting that, whether we're talking about Python or Julia or R, every time there's a handoff from a step in the pipeline, it is a chance for things to go horribly wrong. Because the handoff's not clean, you use the wrong tool on one side or the other, you miss something, you leave the security door wide open. So it's complicated. And I think being cognizant that those are the places. And there's a follow-up question that Tom had. Does anyone provide an opinionated approach to Python in the same way that RStudio supports Tidyverse, which provides an end-to-end workflow? That's a place to start. I would say that Anaconda, that distribution, I would say for the last 10 years has sort of served that purpose. VS Code is starting to bundle more stuff together. So you're seeing more of that, as well as PyCharm. But there's not, as far as I'm aware, there's not really anything that is similar to Tidyverse. And I think part of the reason Tidyverse exists is because there's a company behind it. Bless you.
Thank you very much. It's hay fever. I'll add that I think RStudio does have a significant amount of quote unquote market share in development of the Tidyverse. It isn't the only, like there are a lot of people who contribute who aren't employed by RStudio. They do have a tendency to see those people, start working with them, and then employ them as well, which, we could discuss like whether that in the short term, that's I think a wonderful model. I don't know how productive it is for the long-term viability of an ecosystem. And I will compare Anaconda with that, which I think is the closest analog in the Python space, but they're definitively less opinionated and have less quote unquote market share of developers in the community. We've also recently seen, I think people working on core PyData Pythonic stuff are employed all over the place. I mean, I think Microsoft has recently started to employ more and more. We have a whole bunch of people in fan, like Netflix and Project Jupyter have very interesting correlations, right?
Yeah, absolutely.
So I think the ecosystem as a whole is, less opinionated, but I think that may make it more difficult to approach. But I also wonder whether in the long term, that means more things are developed, like many ideas come in, in the open source ethos, right? Right.
I guess there's one other project that I neglected to mention in response to Tom, and that's if you're willing to dip your toe into Docker, the Docker stacks that are maintained by the Jupyter team are actually a good representation of, data science packages that are commonly used or scientific packages. There's different flavors of it. So that is one way. Although if I was a brand new user, would I want to start with Docker? I'm not sure.
I'll also add that something we're seeing, I think people like call it ML ops or whatever this thing is. Essentially, it's infrastructure for not just machine learning apps, but apps powered by data, software powered by data, right? And I think the way I think about it is the premise there is that, when we're building software powered by data, it's a good question. Do we need different software development tools than for, a regular software that's not powered by data? And data changes the game so much that we're seeing tools such as Kubeflow, Metaflow, MLflow, all of these things for getting your stuff up and running in deployment environments and bridging the gap between the iterative, scientist approach of working in something such as a notebook and then getting it deployed and moving local to the cloud. We're thinking about similar things at Coiled. You're thinking about similar things in a collaborative setting as well at Noteable. So it's kind of this big exploding space of all these things that I think are fundamental now.
And even if you went with an ML ops solution, you're still going to have variation from client to client, customer to customer. And so there isn't really the one size fits all. And one thing that Tom is looking at doing is building for citizen data science and small organizations. One of my most favorite projects, and has been for several years now, is Dataset, Simon Willison's project.
I don't know Dataset. I'll check it out.
Oh my gosh, you need to play with Dataset. It's amazing. It lets you take in like a SQLite database, but even like a CSV or Pandas. Like now there's translators between things, and lets you then have like a very rough user interface that lets you do sorting and filtering, querying, and then you can also deploy it very easily. And so it is one of my absolutely favorite projects. And, Simon is, had been at Eventbrite for many years and is very, I think he's like a Stanford journalism fellow or something along that line right now. So very interested in like, open data and how to make things easier to use. So things like Dataset is going to raise the bar on other projects, because you can see, okay, I can do this here. Or who's offering Dataset as a service? Don't know.
So I've just posted the link to it in the chat. It looks fascinating. And as you mentioned, Tom Brown said his interest is in teaching and building citizen data science. And Dataset is aimed at data journalists, museum curators, archivists, local government, and anyone who has data they wish to share with the world. So right.
And I mean, the other thing I have seen, in my travels around the world, outside of the US, there are many different Python ecosystems that are using only the open source tools with great effect. And I think you shouldn't necessarily discount them, but recognize that it may have a longer onboarding trajectory if you're using it for a small nonprofit. That said, what we've seen more is the cloud providers are now offering, Jupyter environments with certain Python packages already installed, which makes it a lot easier to get up and moving. I'm going to let you field the questions because.
Yeah, so I actually wanted to touch upon something. So we've got a few minutes left that you mentioned at the start in terms of who makes decisions around open source adoption in organizations, right? Who's empowered to make these decisions? And then maybe we can wrap up. And I'm breaking my cardinal rule of not asking two questions at once, but I want to go and one of the big challenges is enabling teams to collaborate with data science. And I know this is something deeply close to your heart and what you're working on at Noteable. So both those questions, empowering people to make decisions, whose decisions they are, and how we get teams working better together.
Absolutely. And, although I've said there's a lot of complexity and a lot of this, I don't want to discourage people from starting, because again, start small and then scale is a good metaphor for many things. Who adopts open source technologies? Probably everybody in that particular loop of individuals. Certainly there might be executives that come in and say, company XYZ is using TensorFlow, I need a TensorFlow, whatever that means. And then there are probably DevOps engineers that are like, oh, I've heard about Kubeflow, it might make it easier than deploying things one by one. Maybe not. And certainly data scientists are always, I think, going to want to have some ability to pick and choose the tools that they use to get their job done. So I think you're going to see it from many different standpoints. And I think what we're going to see in the next 3 years is better ways of deploying the libraries and tools that we have. Because we've certainly seen that with the PyData, the traditional PyData stack. It's much easier to deploy now than it was when we started using those tools.
Absolutely.
And I think you're just going to keep seeing that. And from that, I'm hopeful that, some de facto standards will sort of fall in place. But there's also a lot of tension to be when businesses get involved about which de facto standard should be the de facto standard.
Yeah.
So,
Actually, I recall when Fernando Perez's keynoted, I think it was the inaugural JupyterCon. He said we still get requests and issues upon like really foundational stuff in IPython. And he's like, I respect that and appreciate the intention, but we've agreed on this as a very large community. And now we need to move on to the next level. So these are the foundations we've decided to build on.
Right. And I mean, like I mentioned it earlier, like the IPYNB format, it's not perfect, but you can translate the format. But I look at it from what's best for education. And if you start having competing formats, the ability to share notebooks becomes very problematic.
Yeah.
And, but I think there's so much opportunity. I think that there's tons of opportunity for the next level of humans to, share knowledge with each other with compassion. And, oftentimes you're going to have to think for yourself. Does it, if you can't kind of reason, like, does this make logical sense? Because at the end of the day, I think most of the solutions that do work well, people are able to articulate what it is and what it does and what it doesn't do. And I think that's sort of my, at least, way of sorting the world.
Absolutely. So I think I'd love to wrap up in a minute or two, but something that I was interested in and Jonathan Moore has asked about is interested in hearing a challenge or two that you're addressing at Noteable, and perhaps with respect to collaboration and compassion in data science.
Yeah. So I can't say a whole lot at this point. We're still relatively new, and we are doing Vancouver Data Jam. We are going to be having a bunch of users, and we're starting to slowly introduce folks into a beta. But I think, we came from Jupyter, Interact, Netflix, things like Papermill we developed so that you could schedule execution of notebooks. So I think it's not much like Coiled is built upon Dask. I don't think it's too far a stretch of imagination to think that Noteable wouldn't have a lot of those elements.
Awesome.
Which is my way of saying, please ask me that question in a month.
Yeah, and I've just gone to notable.io, and it says, meet Noteable as the collaborative notebook experience that goes beyond silos and breaks down barriers for your data teams. And there's a name, you can enter your name and email to request beta access, which you'll get at some point. So
right.
If people want to do that, they definitely should.
Thank you. Yeah.
Well, and thank you. I always love chatting with you, Carol, and this was, beyond my wildest dreams. So thank you.
Oh, you're too sweet. I had a blast, and Christiana, who has been happily working behind the scenes, we had a great chat at the start as well. So, and thank you everybody that came to listen.
Thank you for joining, and thanks for the great questions as well.
Yeah, definitely. Everybody be safe.
Exactly. All right. Thanks, everyone.
Take care. Bye.